Hello, today we're gonna do a shader that will create this pixelation effect. So let's start by declaring our variable, which will be a uniform float, pixel size with a range from 1 to 64 with a default value of 0. This controls how large each pixel block will appear. Now let's go into the fragment shader. We first grab the resolution of the texture we're sampling from. This tells us how many pixels wide and tall it is. So for that, we're going to have this variable called textRes with this function texture size, the texture. Then we have to convert the UV coordinates into actual pixel coordinates by multiplying by the texture resolution. So UV times text underscore res. Then we divide the pixel position by pixel size. So let's create this variable called block underscore index for that. And we do that to find which block the pixel belongs to. After that, we're gonna create another variable to floor the value to snap the top left of the block. So for that, we're gonna declare vec2. I'm gonna name it block underscore index underscore floor. So we're gonna use this floor function, and we're gonna pass the block underscore index. This is basically like saying, hey pixel, you're in block number 29 on the dex axis. Now we find the center of the block, and the reason why we do that is because we want to sample the texture only once, right at the center of each block. This is because we want to get the clean pixelated look. So for that, we're gonna declare another variable, will be a vec2, will be called block underscore center underscore position. And we're gonna pass the block underscore index underscore floor multiplied by pixel size plus pixel size times 0.5. And since we converted our UV coordinates to actual pixel position, we have to revert that. So we do that by dividing the block centered and our text resolution. And we declare a variable to store those values. Now we sample the color just once at the center of the block. The color will be used for all the pixels inside the block. So for that, we're gonna use the function texture with the texture in using our block underscore UV as a parameter. We also grab the original alpha from the texture using the original UV. This way, if the texture has transparent parts, we will preserve that. And finally, we output the block color multiplied by the alpha to get the final pixel color. And for that, let's just plug those inputs into our constant color. And here's the effect in action. You can see how increasing or decreasing the pixel size changes the level of pixelation in real time. So it's very customizable and great for stylized games. However, we could make this shader more compact and cleaner for a better way to visualize or to reduce the amount of code. We will start the same way by getting the texture resolution using the texture size. And this line now compresses all the block logic we wrote before, so let's break it down. Basically, UV times res converts to pixel space divided by pixel size, which finds the block index. We floor all the value to snap to the top left of the block, times pixel size plus pixel size times 0.5 centers inside the block. And we divide it by res to convert back to our UV coordinates. It's all the same math, just packed into one expression. Now what we have to do is we have to sample the color at the center of the block. And for that, we're gonna declare a variable color, which is a vec4, and we're gonna plug our texture using the block UV. And to finish it, we're gonna plug some values into our constant color, which will be color times our texture. We multiply the color by the original alpha to keep the transparency intact, as we did before. And as you can see, we have the same results as we had before, with way less code, with a cleaner version of the code. And that's it. Thanks for watching. Don't forget to like and subscribe. See you next time.